So we're finishing up our our ligation. It's been about 23 minutes, room temperature. So now we are ready to transform. So I got some chemically competent cells out of the -80. Those just finished thawing, and we have some KCM. So I think we've done this protocol before, but as just a quick reminder, we're going to add in 30 microliters of KCM into our competent cell mix. And then that goes back on ice. I'm going to adjust my P200 to 70 microliters. And then I'm going to put our cell mixture into the ligations directly. So you don't need to do anything. At this step, if you were wanted to pause it, you would probably want to do a zymo cleanup. But usually if you're going at this point, you're just going to go all the way through the whole procedure. Another option, which is definitely not recommendable, is to just throw it in the freezer, but that should work if you think you're going to get really high efficiency. So 70 microliters, I'm going to mix it up real quick, make sure that all that KCM gets equally distributed. Pull up 70 microliters, checked it, and 70 microliters again, got a little bit left over. Close it, and flick it, tap it down on ice. Flick it, tap it down on ice, so I have two samples. Pause, clear, start, or I guess start, clear, stop, start, and then we let that chill on ice for just a couple of minutes. So you're supposed to let it be on ice for about 10 minutes, and during that time, the DNA, all the ligated DNA is going to start sticking to the surface of the bacteria. So you can kind of think about it like, I don't know, a coyote in the desert. If he runs through a scrub bush, he might come out with a bunch of little things all over him. And right now that's what's happening here, is our bacteria is getting a bunch of DNA stuck on it. And we want to have as much DNA stuck on the surface of our cells as possible, so that when we heat shock it, the DNA will slip inside, and then we'll be able to select for the resistant plasmid. So we've been going for about a minute, and I will just walk over. Oh, actually, let me just put the KCM away. So always remember to return your KCM back in the fridge. And one other note is that we're going to be doing ampicillin. So we don't need to do a recovery for ampicillin, because ampicillin does not target either the DNA replication or the RNA synthesis or the ribosomes. So this is just kind of a peptidoglycan-based selection. So we can just plate directly after the transformation. So we just have this pre-labeled already, and we're going to bring our cells on over to the heat block. We're going to want to put some water in here. Looks like somebody's already done that, but always fill it up with water so that you get good thermal contact. If you don't use water, then your tubes are going to have air between them and the heat block, and you're not going to get a lot of heat going into those cells. So we've been going for about 2 minutes. That's kind of the bare minimum you want to do. We're really cutting it close here, but this should work. So we're just going to dunk our cells into that water all the way, restart our timer, and we're going to wait for about 1 minute. You always want to be sure that you're using this block, not the 55-degree block, which is right next door. So another thing is we're using these size tubes. If you were to use a Petri strip, you could get away with going into the thermocycler, and you could potentially do 96 transformations. Well, not on this one. I guess you could only do 48 transformations on this one. But if you have a lot of transformations, you're going to want to go to either a 96 well format or Petri strips. You can do 8 at a time. Just set this guy to 42, and that's where you're going to heat shock. And then we have a metal block that's going to go on ice that has the same format. So you can go ice on the metal block, thermocycler 42 degrees for about 90 seconds, back to ice. And maybe I didn't make big enough a point, but this should be 90 seconds. So we have, theoretically, it should be 10 minutes on ice after you add your DNA and your cells, 90 seconds on 42 degrees, and then another minute back here, after which point you can either recover or you can begin to plate immediately if you're using an ampicillin-based antibiotic selection. Thinking about anything else, any other comments I can make here. Yeah, I think that's it. So it's been about a minute and a half. If it goes a little bit over, a little bit under, that's okay. I've heard legends of a 20-minute heat shock actually working. Somebody forgot about it and decided to plate it anyways. So now we're just going to let it chill for about another minute on the ice. And since we have ampicillin, we can go straight onto the plating. So we can just put this off to the side, take down our flame, spark it up. Whoop, adjust that oxygen, grab the alcohol, open it up, and we are ready to plate. So, kind of a quick aside, this little pattern on the top of my jar here shows kind of the pattern you want to do when you're plating. So what I try to do is once I add my liquid, I kind of mix it around at the bottom here and get a nice little even surface. Then I'll flame, and off of that I'll try to do kind of a dilution series with my spreader. Flame it again, and then I'll do another one, meaning that I'm just trying to hit the tips. So I'm trying to slowly thin out the population of cells so that if I was to get a lawn in these first two zones, I might start to get individual colonies at the third or the fourth zone. So now that our cells are good to go, we're going to pull them out of the ice and put them right there. And now I can grab the P200. At this point, if I was using something else, like a spec-resistant plasmid, I'd want to be adding plain 2YP. But again, this is ampicillin. You can only do this with ampicillin and carbanicillin, I guess. But, so I can pull out my culture, checked it onto that plate, and then you can toss both of those. Pull out my culture, checked it onto the plate. And if we were using a small-scale competent cell prep, we'd be using a control as well. We'd plate cells that did not have any plasmid put into them on this antibiotic resistance to make sure that they didn't have any ampicillin to begin with. Otherwise, we could not trust any of these colonies. But we're using pre-made, and they've already had QC done on them, so we don't need to worry about that. So now we're just going to spread them real quick. So I'm going to try to make that first little spreading. I'll just keep this here for reference. So I'm making that first spread right there. Just going to flame it off real quick. And then I'm going to do this second thing. Try to get a little dilution series. Now we're going to that third one. And now we're going to do the fourth one. And we're just going to repeat that process with the second one. So back into the alcohol. Tap it off in there, flame it off. Don't go back over your flame, otherwise you might get a little explosion, a little alcohol fire, which is no good. So there we are, we did that first kind of spread, flame it off, and now we're going to go on to that second dilution series, flame it off, third one, flame it off, and final one. Finally, we're going to flame off our spreader one more time. Set that aside. Close up our alcohol. And we're going to let our plates dry. So just kind of put them elevated right next door and let them slowly evaporate for anywhere between 2 minutes to 10 minutes, depending on how wet these plates are. So that is how you do a transformation off of a ligation, and that is pretty much a complete cloning cycle. We'll come back tomorrow where we're going to do a colony PCR off of this, and I'll show you how to pick them.